Good morning, student. Welcome back. Welcome back to Mr. Chen's channel. Today we would like to talk about 9.2. Last time we talked about the system equation, linear versus the nonlinear or the combination. And today we talk about the way to solve for the linear system equation. Okay, so check it out. The first one. Solve the row echelon form system equation by using back substitution. So basically, well, don't worry about the row echelon form yet. So we'll just talk about the way to solve for x, y, z. So row echelon form, we'll get to that for the next sections. So again, this one's a combination of section 7.2, 7.3, which is the same as 9.2, 9.3. So the system equation, linear system with two variable or more than two variable. Okay, so we'll look at that, the first one. Okay, so going to my active inspire right here. So let's take a look at the first one. So y is already solved, so we can solve for z next. So y equals 8, so y minus z equals 4 for the second equation. So that means 8 minus z equals 4. So that means z equals 4. So solve for y, solve for z, so we can solve for x. So x plus 3y, so x plus 3 times 8, and then minus 12 times 4, so that equals 10. And then 24, this one here, 48, so that equals 10. Combine the like term, so x minus 24 equals 10, so x equals 34. So you can always plug in a number back to the equation and check that, make sure that it satisfies the solution. So we got x, y, z, three variable, the length, the width, and then the height. If that's in the three-dimensional space, to plot those points, x, y, z. Okay, so now let's see what else that we got. Okay, so the other one here, so let's just do the one with three variables. Two variable, that's quite straightforward. So solve each system and parametrize the system with the infinite solution. Okay, so if that's like more than one solution set. Okay, let's do this one for C. Okay, so started off with the label. Okay, equation 1, equation 2, equation 3. Okay, so you probably noticed that once we combine the second and the third equation. Okay, so combine the second and the third equation, you'll see that 3a, negative 3a got canceled. So 6b plus 3b, so then that'd be 9b. Negative 2c plus 1c, negative 3c. And then negative 13 plus negative 20, negative 33. And then divide each term by 3. So we got 3b minus c equals negative 11. So let's say this one's the fourth equation. And then in order to get rid of that a, so for the first equation, the next step, multiply the first equation by negative 3. And then combine it with the second equation. Okay, so multiply the first equation by 3, negative 3. So we do have negative 3a plus 9b minus 3c. So that equals negative 42. Okay, so 3 times 4, 12. Yeah, negative 42. And then combine it with the second equation. So second equation, 3a plus 6b minus 2c. So that equals negative 13. Cancel, cancel. So this one, 9b plus 6b, 15b, negative 5c. So negative 42, negative 13. So negative 55 divided by 5, 5, 5. So we do have 3b minus c equals negative 11. So one thing that we noticed, the fourth equation and the fifth equation, they're the exact same equation. Okay? So here's the problem. If that's the exact same equation, so it looks like this one we do have infinitely many solutions. Because that equation they're considered overlapping. Okay, overlapping. Okay, so back to the instructions. So solve each system and parameterize system with the infinite solution. Okay, so this one what we can do. Since a, we don't know what that is, so let's say a equals t. And then in order to solve for the rest of this, so we can say that, so 3b equals negative 11 plus c. So b equals negative 11 plus c over 3. Okay, so for b, negative 11 plus c over 3. And then how do you solve for c? Because this one we cannot come up with the exact value, it's infinitely many solution. So for c, we can just say that it's negative 3a plus 3b over, using the third equation, over negative, well, let's see. So negative 3a plus 3b and then plus 20. Okay, so for c, so again, a is just like t, so using that the new parameter, so negative 3t plus 3b plus 20. Okay, so nothing we can do, we can just using like substitution to find out that the relationship in between one variable to another variable. Okay, so now let's see what else that we have. Okay, so one of the solutions that you can find out, that means just like the unique solutions. But sometimes you'll see it's the same equation. So that means the system has infinitely many solutions, like the one that we just did. And now what about this one? This one is a little bit tricky. Determine a set of possible values of a and b such that the system x plus b minus 1 quantity times y equals negative 2, ax plus 9y equals 4, has no solution or has infinitely solution. Okay, so let's find out what to do with this one. Okay, so if those two equations are equal, so one thing that we notice, okay, so for the first equation, let's just convert that to the same quantity. So let's multiply by negative 2 for the first equation. So what we found here is negative 2x plus negative 2y times b minus 1 equals 4, which is the same as the second equation, ax plus 9y equals 4. So one thing that we notice, so the first equation is the same as the second one right now. So in order to have an infinitely many solution, so that means, well, the coefficient got to be exactly the same. So what this one is showing here, okay, let's just rewrite it. So negative 2x minus 2 times the quantity b minus 1 times y equals 4. And then ax plus 9y equals 4. So in order to have an infinitely many solution, that means the coefficient got to be exactly the same. So that means a must be negative 2. And then over here, negative 2 times the quantity of b minus 1 equals 9. Okay, so in order to have the exact same equation. Okay, so solve for A. So we did it already. Compare and contrast. A equals -2. And then for B, so -2B plus 2 equals 9. So that means -2B equals 7. So B equals 7 over -2. So this one is for the equation that if they do end up with the exact same coefficients. So in order to have infinitely many solutions, so A must be -2. So B must be 7 over -2. Well, if this one has no solutions, so that means these two equations, they cannot be equal. Okay? If they're not equal, so one thing that we can find out here is that, okay, so -2, okay, so that means A cannot be -2. So A could be any other number besides -2. Could be -infinity to -2, or any number from -2 to infinity. And then B could be any number from -infinity to -7/2. And then -7/2 to infinity. Well, if those numbers, they're not equal, so that means the equations, they're not exactly the same. Because that both of them equals 4, so that means the equation got to be lining up with the exact same coefficient. If that's a different coefficient, so that means it's not going to be the same equation. It's not going to be balanced. Okay, so now let's see what else that we have. Okay, so going back to this page. Okay, so the other one is quite similar. To find the values of k, the possible value, solve the system using elimination or substitution. If necessary, parameterize the answer, so using that t. And then the last one I really want to talk about, okay, the solution problem. It's just like setting up the graphic organizer, so like what we did for the previous section. But what about number 7? Again, just wanting to show you the setup here, so you guys should be able to solve for the equation. So find the quadratic equation in standard form that passes through the point -4, 33, 1, -22, 7, 110. So we do know that the quadratic equation is written as y equals ax squared plus bx plus c. So using that x1, y1, x2, y2, x3, y3, so we'll be able to set up 3 equations. So 3 different constant, so we need to set up 3 different equations. So the first one, y equals 33. So ax squared, so -4, quantity squared, because that's x squared, times a, minus 4b, and then plus c. So that would be the first equation. Rewrite it. So 16a minus 4b plus c equals 33. Then the second equation, so y equals -22. So that equals 1 squared times a plus 1x and then plus c. So what this one is showing here, it's that a plus, well, it's not 1x, it's 1b, because x is 1. So a plus b plus c, so that equals -22. And then the third equation, so 7 for the value of x, so 7 squared times a plus 7b plus c, so that equals 110. So therefore 7 squared, 49a plus 7b plus c, so that it's considered 110. And then for the rest of that, just using substitution, elimination to solve for a, b, and c. So the first, second, and the third equation. Okay, so that's it. Thank you for watching the video today. So any questions that you have, so put it into the comment bar. Okay, so from the YouTube channel. So I'll see you guys next time. Have a great one.